Okay, today is 9.3, which are hyperbolas. Basically, a hyperbola is going to look kind of like a parabola opening up and a parabola opening down, or it could be parabolas opening like to the right and to the left. Um, so they're going to behave like parabolas do, except there's going to be two of them. So you're going to have two vertices, you're going to have two foci. The foci will be on the inside of the parabola, just like they've always been. But there's going to be some other aspects that will be new. Um, Again, this is like two cones, and if you slice straight down, one cross section will be like a parabola opening up, and one will be a parabola opening down. Or if you spin it, it could be left and right. So here's the general shape of a hyperbola, and we're going to discuss the values of a, b, and c. Very, very similar to what we've had with ellipses. So A goes from center to vertex, just like it did with ellipses. So here's the center, here's a vertex, I'll label it V, here's another vertex, I'll label it V. That distance from the center to a vertex is A. So then center to this vertex would be another A. C is the center to focus. So from the center to this focus right here, the focus is going to be inside the parabola. Here's another focus inside the parabola. That distance from the center to the focus, that is C. Center to focus. Remember that there's a C in the word center and a C in the word focus. So that's C, the letter C. And B, similar to with ellipses, B is the center to the edge of the minor axis. So the major axis is where the vertices and the foci lie. So those are lying horizontally. So the minor axis in this case would be vertically. So from the center to the edge of that minor axis is the value of B. So center to this edge is B, center to this edge is B. So you're going to notice that there is this box, this dashed line box, and the box is made up of A and B. So if you go from the center out this way A amount and out that way A amount, and then center up B amount, down B amount, that is going to form this box. And then diagonally through the box, through the edges of the box, through the center, through the edges, that's your asymptotes. It's important to know where the asymptotes are because that's going to determine how wide or how skinny your parabolas are going to be. So in the formula, A and B are going to be squared. They're going to be in the formula just like they were for ellipses. Here, I'll go to the next page. So here's our formulas for hyperbolas. So you're going to have A squareds and B squareds in the denominators. But here is some major differences. In ellipses, the x stuff was always first, but now in hyperbolas, if the x's are first, it's going to be horizontally aligned, and if the y's are first, it's going to be vertically aligned. So the x stuff and the y stuff changes now. Also, there's a minus sign instead of a plus sign. So if it was an ellipse, there would be pluses. With hyperbolas, they're minuses. And before with ellipses, the a squared would be underneath either the x's or the y's, and it would change, and a squared was the biggest one. But now the a squared is always underneath the first fraction, and b squared is always underneath the second fraction. So the only thing that changes now are where the x's and the y's are located. Remember that your center is still going to be HK, and you just need to be careful on a problem like this, that the H's always go with the X's and the K's always go with the Y's. So you'd have to look at this number first, then this number in order to get your center. Also, this is different. For ellipses, it was c squared equals a squared minus b squared, but now for hyperbolas, it's plus. So up in the picture here would be your center. Here would be a vertex. Here's another vertex. These dots on the inside, those are the foci. From center to vertex is A. From center out to the minor axis is B. So out to here would be B as well. Again, that box is made up of A and B. And then the asymptotes go diagonally through the box. Make sure your parabolas get really close to them. Same thing over here. Here's your center. This is vertically aligned, so your vertices and your foci are going to go vertical. So then here's another vertex and a foci. A still goes from center to vertex. B goes from center to the edge of the minor axis. Those make up the box. Put your asymptotes diagonally through them. That's about it for hyperbolas. So we're just going to kind of practice this now. So we're going to graph this hyperbola. So first thing I want you to notice is that the y's are first. So when the y's are first, like here, that means it's going to be vertically aligned. That's helpful to write down. A squared is always underneath the first fraction, and b squared is underneath the second fraction. Now, this time a squared won't necessarily be the biggest number, even though it is here. Not every hyperbola will work that way. So I have another example coming up. But in this case, it does happen to be the bigger value. So that would mean that A is 4 and that B is 3. The center, be careful here. The H always goes with the X's, so it'll be a -3, and the K always goes with the Y's, so it'll be a +2. So -3, +2 is our center. It's vertically aligned, so I'm going to go up to get my vertices, up and down to get my vertices. So A is from center to vertex. So I'm going to go up 1, 2, 3, 4 and put a vertex there. This is my center, and I'm going to go down 1, 2, 3, 4 and put a vertex there. So my vertices are at, that would be -3, 6, and -3, -2. Let's see, B goes to the edge of the minor axis. So if this was aligned vertically, that's our major axis. So the minor axis would be going horizontally. So I'm going to go out from the center 1, 2, 3 to the right and 1, 2, 3 to the left. This is going to form that invisible box. So join up all of these marks. Okay, and then the asymptotes are going to go diagonally through. So through the center, through these edges, corners. Okay, so kind of get those drawn in so you know how wide to make your parabolas opening. So now the parabolas, they're going to start at your vertex and they're going to get really close to your asymptotes, but not actually touching them. And again, it's vertically aligned, so they're going to open up and they're going to open down. Okay, now the only other thing we need are the foci. And C is from the center to the foci. So I have to figure out what C is. So we have the c squared equals a squared plus b squared. Now that it's a hyperbola, that's a plus sign. So c squared is going to equal a squared, which was 16, plus b squared, which was 9. So that means that c squared equals 25, so c is 5. And the foci are going to be aligned with the vertices. So I'm going to go 5 up and down from the center. So that would put one focus right here. That's 5 above the center, and the other focus would be 5 below the center. And those foci should be inside the parabolas. All right, that's what the graph would look like. All right, next problem. All right, when I look at this, it looks a little bit odd. The equation looks weird. If I go back a couple, you'll notice the equations are supposed to equal 1, just like ellipses did. So if I want to make this equal 1, if I divide by 16, that'll do it. Okay, so now we just need to reduce. So this 4 over 16, that'll reduce. And then I'll have a minus y squared over 16, and then it'll equal 1. Now, just remember, when you see just a plain x squared, you could consider it like this to make it look even a little bit more like the equations that I had. So we can tell that the center is going to be at 0, 0. Okay, the x's are being squared first. So that means that it's going to be opening left and right. Or we could say horizontal. So the vertices and the foci are going to lie on a horizontal axis. The a squared is always underneath the first fraction. So here's a case where the a squared is not the bigger number. So that's what people get kind of confused between ellipses and hyperbolas. In ellipses, the a squared is always the bigger one, and it'll change whether it's under the first or second fraction. But in hyperbolas, the a squared is always under the first fraction. So that means that a is 2 and b is 4. All right, so we can start kind of putting some stuff on our graph. So the center is at 0, 0. It's going to be opening left and right, or horizontally. A goes from center to vertex. So then I know I'm going to be going to the left 2 to get a vertex, and I'm going to be going to the right 2 to get a vertex. B is the center to the minor axis. So from the center, I would go up 1, 2, 3, 4, and I would go down 1, 2, 3, 4. And now I'm going to make that kind of invisible box, sort of. And then the asymptotes are going to go diagonally through the corners of the box and through the center. I can draw in my parabolas. Start at the vertex, get them really close to the asymptotes. So these are pretty wide. All right, and now I need the foci, so I need the value of c. C squared equals a squared plus b squared in hyperbolas. So c squared is going to equal a squared, which is 4, plus b squared, which is 16. So that means that c is the square root of 20, and that is like 4.47, about 4.5 for our graph. So I need to go horizontally from that center about 4.5 to the right, 1, 2, 3, 4.5-ish. There's a focus, and about 1, 2, 3, 4.5 to the left. And remember, those foci should be inside those parabolas, kind of like a Pac-Man eating a dot. All right, so that's that graph. And then here's our last one. This is the kind where we need to complete the square. So I want to group all my x's together. So 4x squared plus 8x. And I want to group the y's together. negative 3y squared. Oh, there's no more y's. And then I'm going to move that constant 16 over to the other side. And we're going to complete the square. So I need to factor out this leading coefficient of a 4. So I'll have x squared plus 2x, and then I'm going to leave room in the parentheses to complete that square. And then I'll just leave this as a minus 3y squared equals negative 16. All right, so I'm going to take the 2, divide it by 2, square it. So I'll get a 1. Now, just be careful. I really altered this left side of the equation by a factor of 4, so I have to add 4 over to the other side of the equation. And then now I will have a 4 out front, and then this will factor into x plus 1 quantity squared minus that 3y squared, and then over here I'll have a negative 12. Now, our equations need to equal 1. So that means in order to make this equal 1, I have to divide by negative 12. So I'm going to divide all of these by negative 12. So that means when I reduce, I will have a negative 3 underneath here. And then this will reduce, and it'll be a positive, because the negative divided by negative is positive. And that will reduce to a y squared over 4. And then this will equal 1. Now, hopefully something should look a little weird to you. There's a plus sign here, and hyperbolas always have a minus sign. Well, we can easily fix that if we just swap and put this fraction second and put this fraction first. Because this negative could get moved out in front, and then we would have that quantity x plus 1 squared over 3. So now my center, be very careful, the h always goes with the x's, so we have to write that first, and then the k goes with the y's, so that would be a 0. So the center is at negative 1, 0. The value of a squared is always under the first fraction, and b squared is always under the second fraction. So a would equal 2, and b would equal the square root of 3. And if you needed to find c, remember that c squared equals a squared plus b squared. So a squared is 4, b squared is 3. So that means that c would equal the square root of 7, which is like 2.7. So you would have everything you would need in order to make your graph. Because the y's are squared first, that would mean that it's opening up and down. Or if you wanted to think of it as vertical for the major axis. So my center would be here at negative 1, 0. A goes from center to vertex, and I need to go up and down to get to my vertices. So I would go up 2 to get a vertex, and I would go down 2 to get a vertex. B would be square root of 3, which is about 1.7. That would go horizontally to get the edge of the minor axis. So I would go out about 1.7, just kind of eyeball it, and then make your invisible box. And then put your asymptotes going diagonally through the box. And then you can make your parabola shapes from the vertex, getting really close to the asymptotes. That should be hitting that vertex. And then for your foci, that's where we need the value of C. Center to focus is C. So I got to go about 2.7 up and down because it follows on the same axis as the vertices. So go about 2.7. You can barely see it right there. And then from the center, go 2.7, about there. It's a little hard for me to draw with this board that I'm using, but I think you get the idea. All right, so then the next video will kind of show you going backwards and writing equations. Okay,